Hi, this is Maggie. This video is an introduction to writing objects and classes. One of the design principles behind object-oriented design is encapsulation, being able to create a part of a program that is as independent of the rest of the program as possible. This allows you to create and fully test a small component. So one purpose of encapsulation is that it facilitates writing correct code. It also allows you to create reusable components, which is both time-saving and facilitates writing correct code. We will start with a very simple example. We'll encapsulate some functionality that you'll hopefully see as being coherent and reusable. An object is data encapsulated with operations on the data. If we allow the data to be transformed only through the operations defined on the data, then if we have written the operation code well, the data will always be in a stable state. The simple example we'll begin with is a shopping list. The data of a shopping list is the list of items, and the obvious operations are add, remove, and view the list. This is mundane. It's the sort of thing that people use every day when they talk to their smart speakers or access their shopping lists using a web or mobile interface. As I've described it, we could use a regular Python list for this. So let's give our shopping list one more feature. Let's store all of the items that have ever been added to the list. This could eventually be developed into something smart, something that analyzes when items are placed on the list and makes suggestions, because who doesn't want their phone saying, "Don't you need milk?" For now, we're keeping it simple. This is our simple example. So our data is the current shopping list, but also the list of all items ever placed on the shopping list. And our operations are add, remove, and view list. We will also want to view the all items list. So let's program this. I've opened a new file and I've called it shoppinglist.py. That is the name of my class, and it's also going to be the name of my file. A class is like a type definition. We're defining a shopping list data type so we can make and use shopping list objects. In the past, we've made and used objects, list objects, surface objects from pygame dictionary objects, but now we're defining our own object. Inside the file, I'm just going to define a shopping list class. So this will be sort of like function definition. I'm defining something to use later. At the top, I write class, all lowercase, and that's a keyword. You can see it turns orange. And then the name of my class, which is shopping list. You might notice this defies our previous naming conventions. Well, this is the reason for our naming convention of beginning variable and function names with a lowercase letter. It's a standard naming convention that classes are named beginning with an uppercase letter. When an experienced programmer sees an identifier beginning with an uppercase letter, they immediately think class. This is why you don't name variables or functions with an uppercase letter. You're communicating the wrong thing. Like if you made a red octagonal sign and then wrote go on it. Most people in the US would consider it a mixed message because an octagonal red sign means stop, but you've written go. Okay. And we also run the two words together. Shopping list, also generally against Python conventions, except when you're naming a class. So a class name really does look different from a variable or function name. After the class name, we write a set of parentheses and then a colon. And the body of the class, or the class definition, will be indented. No surprise there, I'm sure. Now, there will be a docstring at the top of our class, but I'll return to that and write it later. Right now, I'm going to define the fields of the class. That means the data that each object will contain. Remember that our data for a shopping list object is going to be two lists. I'll add a comment that I'm annotating object level fields. and then I'll write underscore items, note the underscore, colon list, and underscore all items, colon list. Another naming convention explained. For now, as a rule of thumb, consider that we will name the fields of an object, the data, beginning with an underscore. And that is why we don't use an underscore to begin the name of other identifiers, because it is reserved for this use, which we won't discuss in detail here. And now, the operations on objects of type shopping list. We want to be able to add an item, remove an item, and view both lists. For viewing the lists, I'm going to return a copy of the lists. I'm not going to print them to the console because I want this to be more abstract. I want it to be usable with any interface. If I write this to return a copy of the list rather than print it to the console, then this could be used with a smart speaker or a graphical user interface. This is another general rule to consider. Your object should represent and allow access to its data in well-defined ways. But unless it is itself an interface object, like a window or a button, it shouldn't interact with a human user. We are designing this to interact with other parts of a system. Before I write any of those methods, I'll need to write an initializer method. I'll sometimes refer to this as a constructor method. That's a method that constructs an object from a class definition or is invoked when an object is first constructed. Our initializer will give initial values to the fields of the object, so we're initializing it. An object initializer has the name underscore underscore init underscore underscore. Note the two underscores before and after the word init. So def, init, and then I have my parameter list. Our parameter lists for all of our methods will begin with the parameter self. That's a reference to the object receiving the message. Hold on to that thought for a moment if it doesn't make any sense. You may have to do some things by reflex until they make sense. Begin every method with self. Now, init should also take any values needed to initialize the object as parameters. But we're going to initialize our shopping list to an empty list, so there are no parameters. And the return type is none. So, inside the init method, I'm going to write self dot underscore items equals open bracket, close bracket, the empty list, and self dot underscore all items equals the empty list. So I initialize both of those fields to the empty list. Fields are always going to be prepended with self. If I don't prepend a variable with self in a method, then it's a local variable and not a field. I want to give our object an initial state, and that is to be an empty shopping list and an empty list of all items ever ordered. And so I prepend those fields with self, and now when somebody creates an object, it has those two fields as data. Now let's write add item. That will take self as the first parameter, and then the item to be added to the list, that will be a string, and within the method, I'll add the item to the shopping list. And I'll check to see if it's on the all items list, and if it isn't already there, I'll add it to that list too. I'm going to allow duplicates on the shopping list. I've noticed that my smart speaker lets me add stuff repeatedly and it doesn't care if I've told it I want apples 3 times. So I'm going to duplicate that functionality. But if we did that for the all items list, it would become ridiculously long and difficult to read. Now, importantly, when I'm referring to my lists, I prepend with self. I'm referring to the data of the object. If I wrote simply _items or _all items, those would be local variables. Local variables disappear when a function is finished executing. My fields are part of the object and persist or exist as long as the object exists. Let's write remove item. And parameter list, same as for add item, self followed by the item of type string, and it also returns nothing or none. Remember that Python will throw an error if I try to remove something from a list that isn't there. So I'll check that the item is in the list, and if it is, I'll remove it. I won't remove it from the all items list, of course. And remember, prepend my field with self ... Now, for get list and get all items, I'm going to return a copy of each list. This is because I don't want to return a reference to my objects list, because then the part of the program that asks for it could inadvertently or maliciously change my list. My class is going to protect the object data. It can be manipulated in exactly 2 ways. An item can be added and an item can be removed. It can be accessed in one way. The user of this class can have a copy of the list. That's part of the idea of object-oriented design. Data is protected. More than data, the implementation is protected. Right now, I've implemented this data as 2 lists. But if I started to write the smart version of this class that I talked about earlier, I might decide to change this to a different format. Perhaps one list of all items that were ever added to the shopping list with an indicator of which of those items are on the current shopping list. It doesn't matter if I change the implementation if no part of the program outside of my class is depending on a particular implementation. As long as the public part of my class still works the same, and that's the methods, then I can do what I want to update the implementation. So let me write these methods. And I'm going to return to that doc string at the top of the class now. This doc string will talk about what parts of this class are available for other parts of the program to use, called the public parts of the class. That's the methods. I'm going to pause the video, write that docstring, which lists the public methods of the class, and return. Okay, that's written. So this is a class definition. I define the data of the class, or fields, and I define the methods, which are the operations that work with the fields. And remember that each method has self as a first parameter, and when we are referring to the fields, we prepend with self. If we were going to call a method from within another method, we would also prepend with self. Now this is a program that uses this class to create a shopping list. At the top, I import the file with the class definition so we can use it. I do that by writing from ShoppingList import star, where ShoppingList is the name of the file. The file is shoppinglist.py, so we don't use the .py part. Importing this way allows me to use what's defined in the file without prepending with the file name, which can make the code longer and harder to read. Here's where I create the list. My list equals shopping list, open paren, close paren. That line of code creates a shopping list object in memory, referenced as my list, and it invokes the initializer or constructor, the init method. You might notice that I didn't pass an argument to match the self parameter. You will pass an argument for every parameter in order except self. Python inserts that one for you. After that executes, the object myList consists of an empty shopping list. Now I send it 3 messages. I invoke add item 3 times, adding milk, bread, and peanut butter, and then I print out the 2 lists by invoking getList and getAllItems. Think about what you would expect this to print. We'll run it in a minute. And then I remove bread and add it again, and then I remove milk. It's a quick little test to make sure there's only 1 bread on each list, and then to make sure milk gets removed from the shopping list but not the list of all items, and I print them again. Did it work? I'll run the program. Okay, that is a very quick overview of a simple class and creating one object from that simple class and sending it a few messages or invoking its methods. What I recommend you do is see if you can recreate this class without looking at the code or the video, and see if you can recreate the program that creates a shopping list object without looking at the code or the video. Once you have that working, enhance this program by creating more than one shopping list object. Notice how each shopping list object maintains its own data. That's what that parameter self is. It's a reference to the object receiving the message. When I write myList dot and then a method, myList is the self that gets passed to the method. So when we work with the list or the all items list, it's the lists from my list that are being referenced. If you then make another list and send it a message, that list will be self, and it'll be the data associated with that list that's being referenced. So practice with that, predict the results, and when you can recreate this program and make some changes to it, you're ready to move on.